Hello student, today I am going to discuss here thermodynamic process. So what is thermodynamic process? So thermodynamic process are different types of process. Are there isobaric, isochoric, adiabatic and isothermal process. So different types of thermal process we'll discuss in this presentation. Now move to the next slide. So topic to be covered. So here the showing the thermodynamic process should be covered here. First one is isothermal process and adiabatic process, isobaric process, isochoric process and cyclic process. So these topics should be covered in coming slide. So here showing the thermodynamic process that we discussed in previous slide. So when a thermodynamic system change from one state to another, the operation is called a process. So these process involve the change of condition, that is temperature, pressure and volume. So there is various types of thermodynamic process are there. First one is isothermal process, another one is adiabatic process, and another is third one is isobaric process and isochoric process and cyclic process. So just see that isothermal means here the temperature is constant, and adiabatic is uh, heat is constant, and isobaric is pressure is constant, and isochoric is showing the volume is constant. So now move to the next slide. Here they're showing isothermal and adiabatic process. So isothermal process is the process in which the temperature remain fixed, and term is isothermal process. So it is often achieved by placing the system in a thermostat, that is a constant temperature bath. For an isothermal process, del T is equal to 0. So another process is adiabatic process. So those process in which no heat can flow in, into or out of the system are called adiabatic process. So adiabatic condition can be approached by carrying the process in an insulated container such as thermos bottle. High vacuum and high polished surface help to achieve thermal insulators. For the adiabatic process, equation is del Q is equal to 0. So there's here showing the two types of process are there: isothermal process and adiabatic process. Here showing isobaric and isochoric process. So isobaric process are that those processes that which take place at constant pressure are called isobaric processes. For example, heating of water to its boiling point and its vaporization take place at the same atmospheric pressure. So these changes are therefore designated as isobaric process and are said to be take place isobarically. For isobaric process, the equation is del P is equal to 0. So another process is isochoric process. So those processes in which the volume remain constant are known as isochoric processes. The heating of a substance in a non-expanding chamber is example of isochoric process. For isochoric process, the volume remain constant, showing del V is equal to 0. So here showing two types of process are there: isobaric and isochoric process. Isobaric where the pressure remain constant, and isochoric where the volume remain constant. So now move to the next slide. Another process is cyclic process. So in cyclic process, when a system is given state goes through a number of different processes and finally return to its initial state. So the overall process is called a cycle process. For the cyclic process, del E is equal to 0 and del H is equal to 0. So internal energy and enthalpy is 0, means initial and final process means covered by the cyclic means states of the system. So a cyclic process is a system whose state goes through the number of different processes, finally return to the initial stage, and overall process is called a cyclic process. So here showing the reversible and irreversible process. So a thermodynamic reverse process is one that takes place infinitesimally slowly, and its direction at any point can be reversed by an infinitesimal change in state of the system when a process goes to the initial to the final state in a single step and cannot be carried in the reverse order is said to be irreversible process. So a reversible expansion occurs by decreasing the pressure on the piston by infinitesimal amount, means small amount. So the another is irreversible expansion occur by sudden decrease of pressure from P to P dash, and when the gas expands rapidly in a single operation. Here the showing the diagram here, the initial and final position of the piston, so the intermediate position and the final position. So A showing the reversible expansion and B showing the irreversible expansion. So this is a reversible and irreversible process. So here showing the difference between reversible and irreversible process. So reversible process, it take place an infinite number of infinitesimally small step, and it would take infinite time to occur. In irreversible process, it take place infinite time. So another point in reversible process is it is a imaginary, as it's assumed the presence of frictionless and weightless piston. So in irreversible process, it is real and can be performed actually. So another point is reversible process is it is an equilibrium state at all stages of the operation, and in irreversible it is in equilibrium state only at the initial and final state of the operation. So another difference of a reversible process is that all changes are reversed when the process is carried out in reversible direction, and in irreversible process after this process of these types of process have occurred, all changes do not return to the initial state by themselves. So in reversible process it is extremely slow, and irreversible process it is its process is measurable speed, and in reversible process work done by a reversible process is greater than the corresponding irreversible process, and in irreversible process work done is a reversible process is a smaller than the corresponding reversible process. So these are the difference between reversible process and irreversible process. Here showing the unit of work and heat. So unit of work in joule. So 1 joule is equal to 10 to power 7 earth. So 1 earth is equal to 10 power minus 7 joule. So 1 joule is equal to 1 kilojoule is equal to 1000 joules. So this unit will help for the calculation of numerical solving of numericals and problem related to the work and heat. So heat unit of heat is unit of heat is in calorie is a joule. So 1 joule is equal to 0.2390 calorie, and 1 calorie is equal to 4.184 joule. So 1 kilocalorie is equal to 4.184 kilojoule. So sign conversion of heat is that, so the symbol of heat is Q. If the heat flow from the surrounding into the system to raise the energy of the system, it is taken to be positive, that is plus Q. if heat flow from the system into the surrounding, lowering the energy of the system, it is taken as negative, so the sign is minus Q. So this is a sign conversion of heat for any process used in problem solving in numerical. So here the showing solve example problem. So calculate the pressure volume work done when a system containing a gas expand from 1 liter to 2 liter against at constant external pressure of 10 atmospheres. So express the answer in calorie and joule. So putting this value in this equation, W is equal to minus P external in V2 minus V1. So pressure is 10 and putting the value volume 2 to 1. So the W is minus 10 atmosphere. So after calculating this value in calorie, so find this calorie and joule. So use this types of numerical problem will ask for examination. Here showing the isothermal reversible expansion work on ideal gas. So the reversible expansion of gas take place in a finite number of infinitesimally small intermediate steps. To start with, the external pressure P is arranged equal to the internal pressure of gas P gas, and the piston remains stationary if P external is decreased by an infinitesimal amount, that is del P. The gas expands reversibly and the piston moves through a distance, that is dl. So this diagram showing the piston movement, that is dl, and the initial and final the pressure is showing P gas and P externals are showing there the single intermediate step and initial position and ideal gas. So dp is a small amount for all practical purposes. So P external is equal to P gas is equal to P. So work done by the gas is one infinitesimal step. dW can be expressed as dWPA into dl. A is a cross section area, so overall dw is a P into del V. So del V is an increase in volume, so the total amount of work done by the isothermal reversible expansion of ideal gas from V2 to V1 is therefore, so by the ideal gas equation solving this, so we find this equation will help for the calculation of numerical. So now move to the next slide. This equation P1 V1 is equal to P2 V2. Solving this equation, now the W is now changed the value, putting the minus 2.30 nRT log P2, P1 upon P2. So isothermal expansion work of an ideal gas may be derived similarly, and it has exactly the same value with the sign changes. Here the pressure on the piston P external is increased by del P, which reduce the volume of the gas. So this is isothermal reversible expansion of ideal gas. Here showing isothermal irreversible expansion work on of an ideal gas. So suppose we have an ideal gas container in a cylinder with a piston. So this time the process of expansion of gas is performed irreversibly, that is by instantaneously dropping the external pressure, that is Px, to the final pressure P2. So the work done by the system is now against the pressure P2 throughout the whole expansion, and is given by the following expression showing like that. So this is the following this equation. So maximum work done in reversible expansion is that here the showing the two types of process, the reversible work of expansion and irreversible work of work done by the gas when the external pressure and is once dropped to the final value P2. So the isothermal expansion of an ideal gas may be carried either by the reversible process or irreversible process. So here the showing the reversible process and this showing the irreversible process. Now come to the next slide. Here the maximum work done in reversible expansion. So showing here the reversible expansion is shown in figure, in which the pressure is initially as the volume increase. So the reversible work done by the gas is given by the expression W minus W irreversible is to V 2 upon V1 PdV, where which is represent the by the shaded area showing here. So if the expansion is performed irreversibly by suddenly reduce the external pressure to the final pressure P2, the initial irreversible work is given by minus W initial P2 V2 minus V1. So which is shown by the shaded area. Thus the mechanical work is not is a state function, as it depend on the path by which the process is performed rather than on the initial and final state. So it's a path function. So the work done is a reversible expansion of a gas is the maximum work that can be done by a system that is gas is expansion between the initial same initial value initial A and the final state, that is A to B. So the work always depend on the external pressure P external. The larger the P external means external pressure, the more work is done by the gas. But the P external on the gas cannot be more than the pressure of the gas. So P gas or a compression will take place. So thus the larger P external can have without a compression taking place is equal to the P gas, but an expression can occur under these conditions is a reversible expansion. Thus maximum work done in the reversible gas expansion of gas. So overall maximum work done in reversible expansion are showing here. So now move to the next slide. Here they're showing the solved example of example here. So 1 mole of an ideal gas at 25 degrees centigrade is allowed to expand reversibly at constant temperature for a volume of 10 to 20 liters. So calculate the work done by the gas in joules and calorie. So putting the value in this equation, we find the solution is minus 410.46 calorie. So using this equation we you solve this problem. So summary of this presentation is that there are the different types of process, thermodynamic process are there. So isothermal process, adiabatic process, isobaric process, isochoric process and cyclic process. So in isothermal process, where the thermal means temperature are same, and adiabatic process where the heat remain constant, and isobaric process means bars means pressure, so pressure remain constant, and isochoric process are there that where the volume remain constant, and cyclic process the initial and final state of process is complete. So there are the different types of thermodynamic process we'll discuss in I have discussed in this presentation. So these references and source textbooks is used for the preparation of this material. So the material presented in this lecture has been taken from various internet sources and websites. So this instructional material is for instructional purpose only. So thank you for watching this presentation.